In this lesson, we're looking at 3D shapes. So remember, no dimensions would be 1 point. One-dimensional is a line. 2 dimensions is a plane. And 3D figures are made up of faces, those flat surfaces, the edges, which are those boundaries between each face, and the vertex, plurals, vertices. That's where you have 3 of your faces meeting. Now, solids can either have all the faces made of planes or have one of them curved. The ones that have all plane faces are your prisms and pyramids. At least one curved is a cylinder, cone, or sphere. So let's look at this figure. This is a 3D figure. What would be its name? What kind of figure is it? Well, it's made with all plane faces. This would be a prism, but what kind of prism? Well, it's decided by what the base is. Notice that these sides are all rectangles. The base is a pentagon. So this would be considered a pentagonal prism. Now for the number of faces. So we're going to write down the number of faces, the number of edges, and the number of vertices. So all it involves is counting, but making sure we pay attention to even the ones that are on the back side. So we have that pentagon, that one, so that's 2. Now around the sides there'd be 1, 2, 3, down here 4, and in the back 5. So 5 of those lateral faces around the sides and 2 bases. That's a total of 7. The edges, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the edges between each of those lateral faces. So 11, 12, 13, 14, and 15. Now count the vertices. Those are those points where they're connecting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next thing you'll be asked to do is find the distance between points in a solid figure. The hardest part is actually figuring out where they're talking about. So my suggestion is always to break down what you have. Find the length of DG. Well, here's D, here's G. So we're talking about that back wall right there. So I'm just going to redraw that part of the figure. That back wall is a rectangle with H, G, C, and D. And we're trying to find this distance. Now notice it's a rectangle, so that means these are right angles. If this side is 12, that means this side is 12 as well. If this side is 8, then this side would be 8 as well. So this would be an 8, and this would be a 12. How do we find that distance DG? Well, that's easy. That's Pythagorean Theorem. 8 squared plus 12 squared would have to equal that value squared. So 8 squared plus 12 squared gives me 208. So that distance DG would be the square root of 208. That's 14.422, but remember we go 3 significant figures. Now remember, if they'd given us units of measurement, like centimeters or inches or anything like that, you would make sure that you included that in your answer. Now the next one is talking about DB. Well, here's D and here's a B. So we're looking at this rectangle on the bottom. So I would redraw just that rectangle. That had D, C, B, A. It's the one on the bottom. D to A was 6. A to B is 12. And we're looking for that length DB. So again, good old Pythagoras. 6 squared plus 12 squared equals x squared. 6 squared plus 12 squared is 180. So that distance is going to be the square root of 180. Remember, we'll go 3 significant figures, so that'd be 13.4. Next one, AH. So let's look back at this figure. A is here, H is here. So we're looking at that panel over here on the side. So I would redraw it. Let's scoot that up a little bit. So it's that side panel. It has A, D, E, and H. This side was 6. How long is this upright side going to be? Well, it's going to be the same as that height there. So that would be 8. And we're looking for AH, so from here to here. Again, Pythagoras. So I would do 6 squared plus 8 squared equals our value squared. And that gives me 100. Oh, so that's a nice value. AH is 10. The last one is a little bit harder to visualize. HB. So let's go back to our figure. HB. Well, here's H, and here's B. So it's going through the box from one corner to the other. So if I did a little cross section of the box, and I'll draw on it right now, going from here to here, here to here. Notice that I get a new rectangle. That rectangle is HFBD. 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 So let's look back at it. Do we know anything about those sides? Well, this side is 8, so this side is 8. 8 and 8. I wish we knew any of these other sides, because if you look at it, that's going across that diagonal right there. Didn't we find DB? We did. So remember how IB likes to use previous answers as you move along. So DB was 13.4. And we're trying to find that distance HB. Again, Pythagorean Theorem. 8 squared plus 13.4 squared equals that distance squared. And I get 243.56. So that distance is the square root of 243.56. HB is going to be 15.6. Now we have a pyramid, and we still need to find some certain distances. So again, break it apart into the pieces that you're looking for. We're looking for SQ, which is this diagonal in the base. So I would redraw just the base. S, R, Q, P. We're looking for this distance. Well, we know S to R is 8. Q to R is 8. So, Pythagorean theorem. 8 squared plus 8 squared equals that distance squared. $128. And we're going to do the square root of 128. So SQ is going to be 11.3. Now, on this problem, they do give me my units, so that would be centimeters. Now, the next one is VR. So let's see if we can figure that one out. VR is that side right there. Well, could we make a little triangle, V to G, and then G to R? Now, if V to G is the height, that would meet at a right angle to that base. So you would get a right triangle. V would be the top, to G, which is the center of that base, out to R. And let's see what we know. Well, they tell us that VG is 12. And that is the height, so it does meet at a right angle. G is in the center of that base. So, if the whole thing is 8, oh, we got a little bit of work to do, don't we? Let's see. This is half of the diagonal. Oh, wait, wasn't SQ a diagonal? So PR, since these are the same lengths, PR is going to be the same length as SQ. And if G to R is halfway, then it's going to be half of PR. So GR is going to be 5.66. Now we can find that length by using Pythagorean theorem. 5.66 squared plus 12 squared equals our distance squared. And notice I don't round until I get to that final answer once I take the square root. And it's 13.267, so that would round to 13.3 centimeters. Now the next one is VM. That's the height in this side triangle, right there. So let's draw that triangle. That side face is V, R, Q. M is right in the middle. And we're trying to find that distance VM. Well, that's also an altitude, so it meets at a right angle. If M is the midpoint of RQ, that's going to be 4 here. Do we know any other sides? Well, we know VR, don't we? We just found it. Oh, so this one we have to do a little different on Pythagorean theorem. This is one of our legs. So x squared plus 4 squared equals 13.3 squared in this one. So for this one, I'm going to take 13.3 squared and subtract 4 squared. And that gives me 160.89. And so VM is going to be the square root of that. And that gives me 12.7 centimeters. Notice that all of our distances are in centimeters. Make sure you put your units. Now, you will also be asked to find the angles. So we're going to end up needing to remember some of our trig. So let's write at the top of our page. So, ka, tua. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Find the angle that plane ABCD makes with AG. So, that's going to be another one of those slices of our picture because AG is going in that diagonal. So we need to look at that rectangle right there. Notice where my highlighter's going. So if I drew that rectangle, that would be A, E, G, C. And we're trying to find the angle that this bottom piece is making with that. So we're looking for this angle right here. Now, do we know anything? Well, maybe if we flip back, we might know some of this. If you flip back to the pages on distance, we had found the distance of DB, which is that diagonal, actually, let's write down all the ones we found on the other page. DG was 14.4. DB was 13.4. AH was 10. And HB was 15.6. So how are we going to use that information? Well, there's a lot of lines that are going to be the same length. In ours, AC is going to be the same length as DB. AG, let's see if we know that one. AG is going through it. That'd be the same length as HB. And GC is the height. That would be 8. Notice that this is a rectangle, so this is a right angle. You could use any of your trig functions. Tangent's a pretty easy one. Tangent is opposite over hypotenuse. So tangent of that angle would be the opposite side, which if I look at the angle, the opposite would be going that way, and adjacent is next door. So that would be the tangent of the angle equals 8 over 13.4. Now how do you undo it to find the angle? Well, you're going to do the inverse tangent. So second tangent of 8 divided by 13.4. Make sure you check your mode. Your mode should be in degrees. So check your mode, hit mode, go down and make sure you're in degrees. Now, it's second tangent 8 divided by 13.4. And I'll pause to let you have a try. Should get that the angle is 30.8 degrees. The next one, It says to find the angle between HB and AB. HB and AB. So we have a triangle here, HAB. HAB. Let's draw that triangle. HAB. And that is a right angle because these are rectangles. HAB. Do we know any of those parts? Well, we do know AB is 12. What other ones do we know? HA was 10. And, well, HB was 15.6. So we know all of those lengths. We're trying to find the angle between HB and AB. So we're looking for this angle right here. That's going to be my theta. That's my unknown. Might as well use tangent. It's easy. Tangent is opposite over adjacent. Opposite to that angle is 10, and 12 is the adjacent. So to find the angle, we're going to do the inverse tangent. In other words, second tangent, 10 divided by 12. And I got 39.8 degrees. The next one, BD and BE. So let's see if we can find out where those are. BD is that length right there. And I said BD and what was the other part? BE. So BD is here. BE is that diagonal. Since that's the last one on that page, we'll go ahead and draw those in. BE is on that face. BD is there. Now, since this is on this face, and this is on a face here, we would have a right angle again, right there. Let's redraw it. Well, I shouldn't have drawn it like that. Let's try it. D, E, B. Do we know anything about any of those lengths? If we look up, DB was 13.4. DE. Oh, that's the diagonal of one of those sides, which was the same as AH. So DE is going to be 10. And we're trying to find the angle between BD and BE. So we're looking for that angle. Well, this time I'm not even going to worry about anything else. That's opposite and adjacent. So the sine of that angle, opposite and hypotenuse, is 10 over 13.4. So to find the angle, we're going to do inverse sine of 10 divided by 13.4. And I get that that angle is 48.3. Could we do the same thing with that pyramid? Let's jot down the parts we found already. We found SQ was 11.3. We found VR was 13.3. And we found VM is 12.7. Calculate the angle SVG. SVG. So this angle up here to the top going down that altitude. So that was a right triangle. SVG. Well, we know VG is 12. That was a definite. Do we know any of the other sides? Well, SV is the same length as VR, 13.3. And we're trying to find this angle up here. Well, I know that this is the hypotenuse, and this one's adjacent, so let's just use cosine. So remember, to find the angle, we're going to do the inverse of cosine. Second cosine, 12 divided by 13.3. And we get that that angle is 25.5. Now, the next one, angle SVQ. Oh, that's like going all the way across and up. Let's look at that triangle. It's going all the way across. SVQ. Well, here going down the middle, that was VG. So didn't we already find this angle? So wouldn't this one be the same? So angle SVQ would be double that 25.5. Next is VMG. Okay, so that's a different angle. Different triangle here. VMG. It's just going there and then going up that way. So, hint, draw the triangle. Or, yes, draw the triangle. VG is that height, and then going out to M. Well, GM was halfway across the base, so that was a 4. Had we found any of those other pieces? Well, we have. This one was 12.7. So angle VMG is this angle right here. 4 is adjacent, 12.7 is hypotenuse. That would be cosine. So you would do the inverse of cosine of 4 over 12.7. (71.6 degrees). Calculate the angle SVR. This one might take a little bit. Let's draw the picture. SVR. So SV. This is one of those faces of the triangle. Well, we know this whole thing is 8. But that's not a right triangle. Well, what if I drew down the middle, would it be? And that little piece would be 4. Do we know any of the other pieces there? Well, I know VR is 13.3. So could I find the angle here and then just double it to get both sides? Well, how is that angle related? That side is opposite hypotenuse. So that would be sine is 4 over 13.3. Now remember, we're only getting half. So the inverse sine of 4 divided by 13.3 is 17.5 degrees. So our whole angle SVR would be double that, so 35 degrees. The hardest part of these problems is going to be breaking down each of those 3D figures into triangles and rectangles so that you can use your basic SOHCAHTOA. You could have also used law of sines or law of cosines. Now try some of the ones in the book.